Okay, this is the chapter 4, and the chapter 4 is about system of equation. Today we study linear system of equation, but I promise that we study non-linear system of equation. Okay? So this is easy. I want to recall the thing you see before in intermediate algebra, no? So let's doing the problem in 2 dimension. 2 dimension is two variables, xy, xy. Entonces let me refresh your memory. For example, let's doing using two methods, substitution and elimination. What is the best? Depending on the problem. No? In this case, you have two equations, guys. I call the equation number 1, equation number 2. I want to enumerate all with the equation 1, 2, 3, 4, 5. Entonces now you see in this case fantastic doing that problem by substitution, because when the coefficient is 1 or -1, is cool, is better the substitution. I want to show you. For example, you take the easier equation, in my opinion, is equation number 2, and you solve for x or you solve for y, either way, because the coefficient is 1 or -1, here is also 1. It's nice, no? When the coefficient is not 1, entonces let's see how we are doing, but in this case 1 or -1, entonces it's easy. By substitution method. I make a decision. There are several ways, no infinity, but there are a lot of possibilities. So now you take the equation number 2. In my opinion, it's easy. I solve for x. Entonces 4 plus y. I move the y to the right hand side. Now in that moment, substitution is the idea for this method. You replace in the second equation, say in another equation, not in the equation that is another equation, you replace x here. So you're right now. It's not x anymore, no. It's 4 plus y plus 2y equals 7. And this is my new equation 1, okay, I rewrite by substitution. This is the idea. X for the expression is equivalent according to the equation 2. Now the rest is super easy. You combine like term, 1y and 2y together is 3y. Is equal to 7 minus 4. I move 4 to the other side. 3y is equal to 3. The 7 minus 4 is 3. Divided by 3 both sides. Obviously, y1. I finish, no, because I need to find the order pair x, y to satisfy the system. Well, we have two variables. But use substitution one more time, y equal 1 in either equation, in the equation 1 or in the equation 2. It doesn't matter, the answer is the same. However, I want to substitution here. It's ready, a part is ready, 2, because x is isolated, waiting for me. So it's 4 plus 1 equal y1, therefore x is 5. Now the solution is the order pair 5, I bring one picture to illustrate the simulation and Desmos of this, but I want to explain something extra. Look. It's important to understand, number 1, that each equation represents a line in 2 dimensions. How do you know that? For example, you take one equation, arbitrary, x plus 2y equals 7. This is one equation, and one equation that contains 2 variables. So in order to determine the degree of freedom of the one equation or one system, you subtraction the number of variables is 2, that 2, minus the number of equations. In this case, we have only 1. and 2 minus 1 is 1. The indicate degree of freedom 1 indicates it's a line, because a line is the geometric object that have only one dimension. However, when you combine two equations, it's different. You have two equations. So I am talking about in the original system, no? We have two equations, and we have two variables, look at, and the degree of freedom is 2 minus 2, is 0. That indicates us that the solution in this case, not always happen, but in this case, is a point. Okay? A point is the geometric object that have degree of freedom 0, because the point have no dimension, no, it's dimensionless. So we have no length, we have no width, it's just a point, infinitesimal point. That is the reason this, and this is the answer, right? This is the solution algebraically, and this is the geometric representation of this case. Everyone follow me?
Yes.
Cool. Let's move on to the example 2. That was the example 1. Example 2 now. Example 2 now. Example 2 is bring a new situation. Ax minus y equal minus 2. This is the first equation, number 1. And 6x minus 2y is equal to negative 4, equation 2. Normally, the system, you using the curly bracket to indicate that this belongs to the same problem, no? So the problem, our problem is a system that contains two equations and two variables. Okay? Let's do it algebraically. One more time, we using substitution. Why? Because I can see in the first equation that at least one coefficient is 1 or negative 1. So I actually, wait. Yeah, but I copied wrong. I copied wrong. The first equation is okay, but the second one. The second is 4x minus y equal, I am crazy. Again. Okay, the first equation in example 2 is ax minus 2y equal 2, positive, equation 1. And equation 2 is 4x minus y equal 5. Okay, now I copy right. So I can see that we can more time apply substitution, because I see one coefficient here, 1. Now you take the equation 2, I copy, rewrite again. You isolate the variable that contains coefficients 1 or negative 1. For example, I copy 4x, bring down, minus 5 equal y. Y I move into the right hand side like a positive. Now, this y, use substitution in another equation in the y place, que is here. Now you copy ax minus 2 times something, and this something you enclose in the parentheses because it's a binomial. So these two, we need to multiply whole thing inside the binomial, because 4x minus 1 equal to. Okay, that is easy because it's one equation with only one variable, therefore the solution is elementary. You apply distributive property as ax minus ax, because negative 2 times positive 4 is negative 8, plus 10. Negative 2 times negative 5 is positive 10. And suddenly happened, wow, look at that, what happened. I try to do my best. However, I cannot solving the x because cancel out this. Positive x, positive ax minus ax together is nothing, 0. And you get this statement that is obvious as false. And when this situation happens, you are doing your best. However, you get the contradiction. And the contradiction indicates us that this system has no solution. No solution. This is the answer. The answer is no solution. Let me try to understand graphically. Graphically is something like that. Okay, this is a typical no solution. The equation, I do the graphic of this equation one by one, and that equation are parallel. And see, they are parallel, never meet. And see, never meet, we have no common point. Therefore, this is a reason that we have no solution. Okay, in 2D, this is the interpretation. Each equation represents the line. These lines are parallel. Then we have no solution. At the beginning, you don't know, but algebraically, the procedure guides you to this. When you manipulate the system and you get the contradiction, one statement gets completely false, it's because we have no solution. But so far, we see one example number one in which you have one solution, 1 point solution. In the example 2, no solution. In the example 3, you see now surprise. In the example 3, we have 3x minus y equals minus 2, equation 1. 6x minus 2y equal minus 4, equation 2. This is my system is given. Now, I try to solve it algebraically. Let me try to do my best. Algebraically is. Let me see. I see one more time that here we have the coefficient 1 or negative 1. Entonces I copy the equation. 3x minus y equal minus 2. Solve for y. 3x plus 2 equal y. So the only thing I did was I move negative 2 to the left, I move negative y to the right. Of course, I change the sign. Now this expression is equivalent to y, I substitution in another equation is that one here in the y place. So we have 6x minus 2 times parentheses because it's a binomial 3x plus 2 is equal to negative 4. Okay, I try to solve this equation. One more time, apply distributive property. 6x minus 6x minus 4 equal minus 4. Okay, now in this moment, I can see one more time you have a similar situation. Okay, I try to do my best. However, I cannot solve for x. X equals something. Cancel out the x part. But you see now, okay, we have true statement. And this is the difference. So what is the interpretation of this? The interpretation of this is we have infinity many solutions. Infinity, spelling, infinity many solution. Okay, so normally when you have, let me try to understand to complete the idea. We are doing graphically because I don't understand very well what means infinity many solution. Okay, look, I have here the graphic of both equations. Oh, wow, unbelievable. Oh, bueno, entonces dale onda. Okay. Again, where are you? Here, over there. Okay, there you go. This is the graphic I did in Desmos. I put both equations. Yeah, you think this. Oh, professor, but I see only one line. Oh, the reason is that actually we have one line. I want to prove. Look, you take, for example, the equation 1, que is 3x minus y equal minus 2. And you solve for y, for example. It's 3x plus 2 equal 1. Actually, I did before. Okay, and this is the same. However, I take the equation 2, que 6x minus 2y equal -4. And we are doing exactly the same. You solve for y, 6x plus 4 equal to y. But I need y alone. So you divide by 2, divided by 2, divided by 2, everything by 2. We have 3x plus 2, equal 4 divided by 2 is 2 equal y. Wow, amazing. You have the same equation. So actually, see, I didn't realize at the beginning get the same. Yes, I know get the same. I didn't decimal, was the same line. I solve for y, I put in slow in step 4, it's the same line. Therefore, when this situation happens, the idea is because these equations are depending. That see, you see, for example, another way to see, another way. Suppose that you take the equation 1, that one, and you multiply the entire equation 1 by 2. 2 times 3 is 6. 2 times -1 is -2, and 2 times -2 is -4, and you obtain exactly the same equation 2. So this equation is the same equation. Do not apport extra information. That is the reason that they are linear dependent. This is the case that we have infinity many solutions. Okay? I suppose that you understand. Yes or no? Yes or no?
Yes, Professor.
However, I want more. I want how you express it in maybe in intermediate algebra. You finish to say, oh, infinity many solution. No. And this algebra, no. You need to specification more clear. So how you represent this? You represent. It's obvious that infinity many solution do not means that all the point on the plane is solution. No. It's on the point on both lines is solution. That one. Let me use another color. Red color is solution. Black color, no. How you define this? Well, you define using one variable get free variable. Free variable indicate when you're talking about free variable is one variable that is independent. Normally, the independent variable is x, que is any real number. Now, how you write the solution? One of the solutions you write like an order pair, but you declare x like an x and y no. Y is 3x plus 2. You, of course, a specification here, okay, x is any real number. This is one way to do. Yeah, this is one way to do. Another way is not necessarily you declare always que x is free. Maybe you can declare que y is free and you move in the x like a function. So another possibility I don't like, but it's possible. You take the equation, that equation, for example, you take 3x plus 2 equal y, and you solve for x is 3x is equal y minus 2 divided by 3 both sides. X is equal y minus 2 over 3. So you same answer or equivalent answer is y minus 2 over 3 comma y, and y again is free variable. Free variable, guys, is because the supposition is, well, actually we have infinity point, no? So is one variable is all real number and another no. Another is depending of this according to the mathematical. Julio Rodriguez start the call. Okay, Julio, welcome. Okay, entonces now, conclusion so far. We have in the system, in linear system specifically, 3 possibilities, guys. We have one solution, like the example 1, no solution, like example 2, and infinity many solution, like example 3. And when you have infinity many solutions, you need to investigate, at least in this subject, In elementary algebra, no. But in this subject, what is the free variable? And you express it, the infinite solution using one free variable. Don't worry too much because I want to explain in detail everything and more example. I promise I want to complicate that part. Okay, this part is not trivial. So far it's just a recall for the elementary algebra, but no always. Okay, everyone follow me so far? Do you understand very well the idea for the free variable? Infinite solution?
Yes.
Okay, cool. Now let's move on to example 4 because I want to illustrate another thing. Example 4 bring me new thing. Okay. Suppose 3x minus 4y equal 1. This is equation number 1. This is the name of the equation, guys. Okay, I call them, if you want, you call any name, Maria, Jose. But no, I normally 1, 2, 3, 4, 5. You enumerate the equation. And 2x plus 3y equal to equation number 2. This is my system is given at the beginning. I need to solve. In this case, so example 1, 2, and 3, we are doing by substitution because we have one variable at least que the coefficient is 1 or negative 1. But in this example, no. We have none. And the coefficients are 3, negative 4, 2, and positive 3. The coefficient is a number in front, the variable, no? So now we are using elimination. Elimination, in my opinion, is the fantastic way. Elimination method. From this problem, everything we are doing is elimination because it's strong. You're using only substitution when the coefficient is 1 or negative 1. Otherwise, no. So what is the idea? The idea of the elimination is to have one coefficient, suppose hypothetically 12y and minus 12y. So I need to do something in order to get same coefficient and opposite sign, one positive, one negative, because I know that this together is 0. Now, entonces there are no infinity possibilities, but there are a lot of possibilities. There are several strategies. For example, in my paper, I create this strategy. You multiply the equation number 1, multiplication time 3. And you multiply the equation 2, multiply by 4. How do you know that? Where come from that number? Well, because suppose you multiply the equation 1, the entire equation 1 times 3 is 9x, because 3 times 3 is 9, minus 12y equal 3. And this is my equation number 1 again, with different coefficients, pero es equivalent. Equivalent no, es linear dependent, it's the same thing. It's the same line, soon. No modification. When you take one equation and multiply by one factor, it's the same line. And you multiply the second by 4. When you multiply the second by 4, we have 8x plus 12y. This was my intention. Okay, you multiply by 3 because 3 times 4 is negative 12, and multiply by 4 because 4 times 3 is positive 1. It's equal 48, que es the multiplication, 4 times 12. And this is my new equation 2 that's equivalent to the original. But what is the difference? The difference is that now in that moment, you put a horizontal line and you put 1 plus 2. You're adding the equation 1 and equation 2. Of course, you're adding by column, the column of the x, the column of the y, and the column of the right-hand side number, que have no variable. Entonces 9 plus 8 is 17x, positive 12 and negative 12 is cancelled. That was the intention. Look here, equal 51, que is 48 plus 3, 51. Finally, divided by 17 both sides, x equal 3. I finished, no? In order to find the y value, you plug in 3x equal 3 in either equation 1 or equation 2. I select, I don't know why, equation 1, because I like, suppose. So you replace x for 3. So 3 times 3 minus 4y equal 1. And you solve for y. 3 times 3 is 9. Okay, minus 4y is equal 1 minus 9. Minus 4y is equal minus 8 divided by negative 4 both sides. Y alone is positive. And the solution is, in this case, unique solution is equal to 3, 2. Let me try. I bring a simulation and Desmos to see. It's a not necessarily mandatory doing, but just in case to verify the thing, I am doing. Look. 3,2. This is the equation. This equal both equations in Desmos. Put one red color, another black color, and you see that there are no parallel, there are no coincidence. Unique solution is the intersection between two lines, is the point 3, 3 is the component x, is the first component, and 2 is the second component. End the story. Elimination. I suppose you remember very well this, no? Or no? Tell me something. Remember or don't remember? No comment. Everything clear or no?
Yes, yes.
Yes. Okay. Let me erase that.
Yes, definitely.
Okay. Now let's move on to the 3 dimension. Okay. A little bit, when you in mathematics, when you increase in the dimension, it's more complicated. For example, let me copy the example 5. Example 5 is x minus 3y plus 3z equal negative 4. And this is my equation that I call number 1. The second is 2x plus 3y minus z equal 15. Equation 2. And the last one is 4x minus 3y minus z equal 19. This is my equation 3, and this is my system. But the geometric interpretation I want to discuss is different. Because you take, for example, one arbitrary equation. I take the first one. Yeah, I see. It's one equation, but contains 3 variables. Que is x, y, and z. Now, the degree of freedom of this equation alone is 3 minus 1 que es 2. That means que 2 is degree of freedom. This equation represent a plane like that. A plane like that. Of course, yeah, it's a representation of the plane, but the plane is infinity in any direction. But the important thing is that the dimension of this plane is 2. Because the plane is a surface que have, you know, length, width, but no thickness. It's totally flat. Okay, so now the representation in this system, equation 1, equation 2, and equation 3 is 3 planes. So this is more complicated. We have more possibility, but I want to explain in detail this, and after we solve it, and after I bring one sketch like that. Look, let me try to make it zoom. And so I want to explain some, and you let me know the conclusion. So we're discussing the system in 3 dimensions that contain 3 equations. Each equation represents a plane. For example, in that part, one equation is yellow, one equation is red, and one equation is green. Okay? 3 equations. Now, let me focus my attention in this example. Okay. We have 3 equations. One is red, one is blue, and another is green. I suppose it's green. But the intersection is the solution. So to be solution, we need common points. Is this one. This is a typical unique solution, because the connection between the plane are not exactly perpendicular, not necessarily perpendicular, but we have only one common point in between 3 sides. However, in this scenario, that one, we have solution, yes, because they are a commons, but not only one. We have infinity many solutions here on this line. So you have infinity many solutions. And of course, when I solve in this system, okay, look like this example, we have one free variable. Remember, in infinity many solution, we have free variable. How do you know that we have only one and not 2? Because the objective solution is a line, and the line degree of freedom is 1. Exactly the degree of freedom of the solution set is coincident with the amount of free variable. Okay, you determine algebraically. No, I want to show you in the example. No, only we discussing the theoretical idea. However, I can see clear, at least in this example, look, that we have no solution. No solution. No solution because we have no common point. We have 3 equations, and these equations are parallel. There are no common point in between these. And remember, we need a common point in between 3 equations. So you have common point in 2 equations and not in the 3rd equation, there's no solution. Okay? What do you think about this example? Do you believe that we have solution or not? This example. Opinion.
Yes.
Solution, we have solution, yes? Yes or no? Yes, you say yes, Victor.
Yes.
Everyone is agreeing that we have solution. So everyone agree?
Yep.
No? Come on, I need to know your opinion. Yes or no?
Yes.
Yes. So no, it's crazy, no? Yes. You are wrong, guys. Let me explain it there. Look. You see intersection, but you see intersection between the yellow plane and the red. It's this line. Okay? And you see intersection also in between the yellow plane and the green. Okay, this line. But we have no intersection between red and green. Remember, you need intersection in between 3 equations. So the thing that we try to find is the common point that satisfies 3 equations. So we need 3 points. The answer is no. No solution, this system. What do you think about this? Opinion.
Yes. Yes.
Yes, we have solution, yes or no?
No.
Yes. Yes.
Yes, no. Okay, okay. She say yes. I hear another no.
No.
No, you are right, mister. No. By the same reason, we have common point in between green and red here. We have common point between red and yellow here. We have common point in between green and yellow here. But we have no common point in between this. The answer is no solution. So far, the three examples that we are discussing is no solution, no solution, no solution. What do you think about this guy? Let me erase this. What do you think about this guy? We have solution or no?
Yes.
Yes. You are right.
Yes.
Okay, I agree 100% with you. But I have a second question. The second question is, we have unique solution like this or infinity many solution?
Infinity many solutions.
Infinity many solution. Very well, mister. Infinity many solution. I have one extra question, third question. How many free variables we declare?
One.
Eh? What do you say?
Solo uno.
Solo uno. Just one. ¿Qué es this? Because so the complicated thing is free variable, you see what part is common in between red equation, yellow equation, and green equation. And you see that yes, we have common in between them. But the common is no point. The common is line. And the line indicates one free variable. Don't worry, guys. I want to explain algebraically how you see free variable. It's just theoretical part to anticipate the thinking we try to do now. Okay. But I need to analyze the third slide here. What do you think about this? Solution or no solution?
No solution.
No solution. Very well. What do you think about this? Solution or no solution?
No solution.
No solution. Very well. What do you think about this? Solution or no solution?
No solution.
No.
No. You are right. Cool, and cool. What do you think about this? Solution or no solution?
Yes.
Yes, solution. I suppose that the solution is unique is this point. I don't know. I don't see very well, but using my common sense, I suppose that yes. And what do you think about this problem? Solution or no solution? Yes or no?
Really many solutions.
Infinity many solution. Very well. The answer is yes. Remember, I have three questions. The first question is, we have solution? Yes. How many solutions? Infinity many solutions. Because I see a line connecting this. And how many free variables? Only one, no? Do you understand very well the idea or no? Do you see?
Yes.
Do you see in the packet and the email I sent today, I sent the PowerPoint, no? Don't open now, no? Of course, no, don't open. But this is a PowerPoint with this figure. You can open at home when the class is over, maybe, to see more clear. Okay, let's come back to example 5 that we have pending. Example 5. I focus it in the example 5. Okay. I copy at the beginning. I know that we are working in 3 dimensions. Therefore, the representation, each equation, 1, 2, and 3 are planes. I don't know exactly what is the position of this plane, but I determine algebraically, not the position, but determine if we have common point or not. Guys, pay attention now. Important thing. You pair 2 equations. For example, you take the equation 1. This is super important organization. Look, I copy the equation 1. Again. Yeah, I copy the equation 2. And maybe the equation can fly in the air. One of y1 and 2, professor. Because I see so important. I see que the equation 1 and equation 2 is ready for elimination because by coincidence, this is my first example, yes, extremely easy. We have negative 3y and positive 3y, thus it's ready for elimination, at least the y part. You add in the one equation plus the two equations by columns. It's important, guys, you organize in the corresponding columns. We have the column of the x, look, the column of the y, and the column of the z. In the same order, we connecting in the solution. So now we combine. This is 3x. The y cancel. No y. Y is missing. Plus 2z equal 11 because 15 minus 45. Here I call this equation equation 4. So far, everyone follow me?
Yes.
Yeah.
Okay. Now, you pair another couple of equations. For example, but this is a crucial moment. I want to explain what is the super important idea. For example, I copy 2 and 3. Okay. 2 and 3 I copy. 2 and 3. But the important idea is, if you eliminate in the first couple the y, you eliminate in the second couple also the same variable. If you eliminate another, you are in big trouble. You never get the answer. So you eliminate in the first couple arbitrary and free the y because the sign is opposite. Yeah, I lie. But in the second couple, of course, it's a coincidence. I create intentionally this example, extremely easy. You are in 2 plus 3 equation, and you have 6x. The y is cancelled. This is important to happen always. You cancel out y here, you cancel out y. Not necessarily always y. Another example is x or z, but the same variable. Minus 2z, because -1 and -1 together is -2, equal 34. Okay, it's 15 plus 19. And it's equation 5. And now you put together, sorry guys, it's too long. It's not my fault. You put together 4 and 5, 6x minus 2z equal 34. This is equation 5. And remember, the new equation 4 and 5 is derivative for the 1, 2, and 2 and 3. But you have in that moment one system that contains two variables. Exactly the same we are doing in the example 1, 2, 3, and 4. Again, I create super easy example. In this example, positive 2c and negative 2c is ready for elimination. So you add in equation 4 plus equation 5, and you have 9x. This is cancelled. Guys, this is only happening in the first example that I create to explain it and not complicate too much this. And this is 45. 45. Now finally, divided by 9 both sides. It's obvious that x is 5. Okay, I feel no. See, I have 3 variables. I need to find x, y, and z. To find the rest of the variable, it's not totally arbitrary. No. Be careful. Because you plug it in the original equation. No, because I have only one. We need 2 more variables. So you evaluate x equals 5 in the equation 4 or in the equation 5. It's the equation that contains only 2 variables. For example, I don't know why I select the equation 4. So 3 times 5, you replace 5 in the x place, plus 2z in the equation 4. I don't know why, but I select equation. So you select another equation, you get the same answer. I guarantee you 100%. This is the beauty of the mathematics. Equal 11. So now 3 times 5, 15, plus 2z equal 11. 2z is equal 11 minus 15. Okay, it's negative 4. Divided by 2. By 2. And by 2. C alone is equal negative 2. The only thing in it is y. To find the y, you plug it in. Yeah, you have everything. You plug it in the equation 1 or in the equation 2 or in the equation 3, because we have in my hand 2 variables. I need to find the y, and that's it. I select, I don't know why, equation 1. Totally free. What equation you decide to use? The answer doesn't change. You replace 5 and x. Because actually, no x is 5 minus 3y plus 3 times something, que es negative 2, is equal to negative 4. So 5 minus 3y minus 6, because 3 times negative 2 is minus 6, equal negative 4. Now, where we combine like term and minus 3y minus 1, the positive 5 and negative 6 is negative 1, equal minus 4, minus 3y is equal minus 4 plus 1. I move 1 to the right hand side, subtraction or whatever is minus 3, and divided by minus 3 both sides is y is equal negative 3. Sorry, it's positive 1. Now, what's the answer? My answer is the triple order x, y, z. Who is x, y, and z in our problem? 5, 1, negative 1. Final answer. So in this case, the intersection in between these 3 equations that represent 3 planes is just a point, a unique solution. Let me show you. I created simulation, not in Desmos, because Desmos is 2D, in another software more sophisticated, but don't worry too much for the graphic in 3D, because this is not our problem. In which you need to take calculus 3, yes, but in algebra, no. It's only to illustrate this idea. So we have one equation, que es the equation green, blue equation, another equation, and red equation. I suppose that the solution is that one. Okay, this one. My question. Do you understand very well the procedure or no? Let me recap quickly. 3 equations, 3 or no. You pair 2 equations, and you make a decision to eliminate one variable. Bam, destroy it. Maybe y, maybe x, or maybe z. You pair another equation and you eliminate the same. This is the most important idea. So you eliminate in the first couple y, you eliminate in the second couple y. So you eliminate in the first couple x, you eliminate in the second couple x. In order to obtain a new system that contains 2 variables, but it's the same, no different. Now the rest is easy. Exactly the same. We apply elimination one more time. And now back substitution. Cool? Let me try another example. No question, guys. You understand very well? Sure. You never see before that, no? In 3D? Oh, yes. You see before? Answer me. Huh?
No.
No.
No. But you understand now?
Yes.
Okay, super. Let's practice. I bring, let me see one more example. 3 more examples. So Okay, okay. 3 more examples of this in 3 dimension. Okay. Example 6, no? Example 6 is minus x plus 6y minus 3z equal minus 8. Equation 1. Positive x minus 2y plus 2z equal 3. Equation 2. And 3x plus 2y plus 4c equal minus 6. Equation 2. This is my new system. I need to solve. Okay. So, well, no, I dedicate a few seconds to analyze one. Okay. So you copy, for example, there are many ways. So you are using different strategies like me, and you are doing well. I promise that you get the same answer. But I need to make a decision because I cannot solve it by any possibility. So I copy equation 1 and equation 2. Why I copy 2? Because I see clear at least the x is possible to eliminate. Yes or no? See, when you're adding equation 1 plus equation 2, yeah, of course, now this is 0, no x anymore. We have 4y because 6 minus 2 is 4, minus z equal minus 3 plus 2 is 1, negative 1, equal negative 5. And this is my equation number 4. After the elimination, one variable, in this case, was easy for me, I don't know, eliminate 1. Well, I pair another couple. For example, in my paper, I copy 2 and 3. Guys, the organization is extremely important. You copy in the same column the variable. Wow, because I see. Well, I'm happy because minus 2y and positive y is ready for elimination. But no, this is totally illegal because I eliminate in the first x. So I need to eliminate x in the second. This is important to understand. Okay. But I try to do my best. I know I need to eliminate the x again. Entonces I propose one idea. You multiply the equation to multiplication. I present this like a box. Multiplication by negative 3. Why? Because negative 3 and positive 3 is ready for elimination. That's exactly I need here to eliminate the x. I copy down. This is minus 3 x. Where come from this? Minus 3 times 1 is minus 3. Minus 3 times 2 is 6. But positive. Minus 3 times 2 positive is minus 6z equal minus 3 times 3 negative 9. And this again is my equation 2. Okay, when you multiply any equation by a number, it's exactly the same plane, no change, it's the same. But now I am ready to eliminate adding 2 plus 3. Again by column. This is cancel. This was my intention. 2 positive and 6 positive is AY. Minus 6 and 4. Positive 4 and minus 6 is 2 minus 2z equal minus 15. And this is my equation 5. And you put together 4 and 5. Let me try. AY minus 2z equal minus 15. And this is equation 5. Yeah, I focus on this system. Well, I try to do my best. I suppose that the easy way, in my opinion, is you multiply equation 4 by negative 2, no? No, by positive 2. By positive 2, because when you multiply, I need positive 2. No, by negative 2, yeah, by negative 2. Okay, sorry, let me try. Well, maybe I copy 4 and 5. Equation 4, equation 5. So the idea is multiplication. This equation by negative 2. So times negative 2. Why? Because negative 2 times negative 1 is positive 2. When you multiply the entire equation 4 by negative 2, we have minus ay, so negative 2 times positive 4 is negative 8, plus 2z, negative times negative positive, equal 10 positive, no? It's 10, no? Yeah. Equation 4. This is the new equation 4 after the multiplication, no? Okay, cool. Now I'm adding 4 and 5. I put a line. Wow, a lot of people cancel. Look, this is cancel, 2. This is cancel, zoom. This is 0, no variable. And it's equal negative 5 because negative 15 plus 10 and negative 5. Wow, what the hell? What is that? This is totally false statement. This is impossible. 0 is not equal to negative 5. So what is the interpretation, guys? No solution. A similar idea in 2 dimensions and 3 dimensions. You manipulate your equation in the natural way, in the traditional way, and when in the middle of the process you see a contradiction because you get the statement gets totally false, it's because the system have no solution. And in the story. I did a simulation also to see, because I want to search. See if this answer is correct or incorrect. But you don't worry too much for this idea. I did a simulation. Look, here the simulation. Here the simulation. So we have the same equation. All right, let me see at the beginning. Yes, it's the same equation. Let me make it zoom. So I discover, okay, we have 3 planes. The green, the cyan color, is this, it looks like a blue, but it's cyan. We have intersection here, it's a line. In between cyan and red is another line, but these lines are parallel. So obviously, we have no common point that satisfy the 3 equations. So in between the couple, yes. So in other words, equation 4 and equation 5 are parallel. Let me copy 4y minus c equal negative 5, get equation 4, no? Now to understand this, let me isolate the y. Y alone is 4y is equal to minus 5 plus c divided by 4, divided by 4, divided by 4. Y alone is equal c over 4 minus 5 over 4. Okay. This is a line, and the slope of this line is 1 over 4. Okay, this coefficient, 1 over 4. Let me try to do the same thing in the equation 5. Equation 5 is ay minus 2z equal minus 15. Again, solve for y, so is ay is equal to c positive minus 15 divided by a, divided by a, divided by a. Y alone is, reduced and lowest term is at 0 over 4 because 2 divided by 2 is 1, and 8 divided by 2 is 4, minus 15 over 8. I don't care this part. The important information is, I try to express it in that way. Y is equal to mx plus b. Actually, it's no x and y. It's y and z. But it's the same. I discovered again this law is 1 over 4. That coefficient is 1 over 4. Now, this is the algebraic way of proof. Okay, these lines are parallel. Therefore, we don't expect solutions. It's obvious. Cool? Any question, guys? You don't worry too much for the graphic part. You are doing algebraically, and you see contradiction, no solution. Okay? Any question? Any question? I want to hear comment. Everything clear? You follow me? You are lost? Totally lost? Yes or no?
Yeah, there is.
Yes, Professor.
Okay. Let's move on to example 7. It's very, very interesting. Always is a little bit complicated when you have infinity many solution because we need to find the free variable. This is example 7. Is 2x plus y equal minus 3. Equation 1. 2y plus 16c equal minus 10. Equation 2. And minus 7x minus 3y plus 4c equal 8. Equation 3. But this system is a little bit weird. Not all we have it, but I create this example to illustrate this idea. So don't expect that any equation is completed. For example, in the first equation, c is missing. In the second equation, x is missing. In the third equation, no missing. Okay, we have the complete collection, x, y, and z. Okay, this is the same idea. But in the organization, let's see what's going on. For example, I pair 1 and 2 again. Not always happen. This is using your common sense. 2x plus y. I copy the first one. But I complete 0z because I need to organize by column. Column of the x, column of the y, column of the z equal minus 3. And this is my equation number 1. Yeah, I put together with the equation number 2. And the equation number 2 is no x, 2y, plus 16c equal minus 10. Okay, cool. Because I know I need to understand what is this tragedy, what is this tragedy, what is this tragedy. Ah, the tragedy, I got it. The tragedy is you multiply the equation 1 by negative 2. Because when you multiply the equation 1 by negative 2, we will have negative 2y. But when you multiply the entire equation number 1 by negative 2, we have negative 4x, because negative 2 times positive 2 is negative 4. Here is positive 1, but multiplied by negative 2 is minus 2y. This is the intention, plus negative 2 times 0 is 0, c, equal, and negative 2 times negative 3 is positive 6. And this is my new equation 1, nice, equivalent, totally depending of the original one, but it's more clear, at least for me, to understand the elimination process. So one more time, we're adding equation 1 plus equation 2. By column, no? This is minus 4x. 0 minus 4 is minus 4. This part is cancelled. That was my tragedy. and 16c equal minus 10. I want to call equation 4. Guys, you have to practice. For this reason, I create online a homework for that one. That you have to practice. Remember, when you are doing the homework, if you don't understand something or you are stuck in some question, immediately you email me and send me the screenshot. I solve it in 5 seconds. I send to back the solution, right? In the homework and the test, no, of course. Let me copy another couple. I select maybe 2 and 3. And the 2 organized is 0x, amazing, plus 2y, plus 16z equal minus 10. This is my equation 2. I want to recopy it. I copy equation 3 now. Minus 7x minus 3y plus 4c equal 8, ¿no? 8, equation 3. Okay, entonces remember, important, 3 remember. If I eliminate y in the first couple, you have to eliminate y in the second. Oh, mandatory. To do this, I multiply the equation 2 by 3, 3 positive, and equation 3 by 2. Why? Because when you multiply 3 times 2 is 6, positive 6, and 2 times minus 3 is negative 6. Let's do it. You multiply 3 times 0 is 0x plus 6y. Where come from this 6? 3 times 2 plus 48z. Where come from 48? 16 times 3 equal minus 30. And this is my equation 2, exactly the same to the region. They are depending, it's the same thing. A multiplication by 2. When you multiply by 2, we have negative 14 x minus 6y. This was my tragedy. Plus az equal 16, because 2 times a is 16, and this is my equation 3. And you adding now 2 plus 3. 2 plus 3 equation is negative 14x. Okay, this is elimination, the same variable. I am happy with this idea. Plus 56z equal negative 14. Because negative 30 plus 16 is negative 14. And this is my equation 5. And you put together 4 and 5. But before this, let me try. This is 10. No, I make a mistake here. Look, I make a mistake. Here, 1 and 2 is negative 4. Because negative 10 plus 6 is negative 4. Okay, let me try to simplification a little bit. I seek in the equation number 4. Wow, there are too many 4, or at least the coefficient is divisible by 4. Entonces es obvio that you can divide if you want by 4 or by negative 4, either way. This is the same equation. Entonces x alone positive minus 4c, because 16 divided by negative 4 is negative 4, equal 1. And this is my 4 equation, a little bit more easy. It's equivalent. Remember, when you do multiplication or divide one equation by a number, the equation stays the same. It's totally dependent. It's the same information. I don't affect that. However, in the 5 equation, you divide by negative 14, and negative 14. Suppose that you don't see that, no problem. You're working with a big number. Of course, I have experience. Yeah, I can simplification. Entonces, negative 14 divided by negative 14 is x. 56 divided by negative 14 is negative 4c. Is equal 1. And this is equation 5. And you put together 4 and 5. Wow, what the hell is that? Do you see it's the same? It's the same. So 4 and 5, unbelievable, it's the same equation. What do you suppose can happen? Opinion. I want opinion. I want to hear opinion.
Infinite
No
many.
solution, infinity many solution, or no?
Infinity many.
Absolutely, you're right, Mister. Infinity many solutions. Alright, how you write infinity many solutions? Well. Let me try. Okay, and actually we have only one relationship, que es x equal minus 4c equal 1. Suppose I make a decision to declare c like a free variable. So c is free, and remember free is equivalent to say que is any real number. Free is totally independent. It's from negative infinity to positive infinity. But the other variable x and y no, because somehow it's connecting by z. So the first connection is easy to see. It's x equal 1 minus plus 4c. Sorry, I solve for x. So you isolate the non-free variable. We have free variable, is ordinary number, and we have non-free variable. What is the free variable in this problem? C. What is the non-free variable? X and y. So you isolate x and y alone as a function of x, que es free. Okay, what should I do? Y. Well, y, y is easy. Because y, I have here, by coincidence, is easy in this problem. Look, take a look. The equation 2. The equation 2 is equation that contains only y and c. But let me try to do my best. Let me try. I copy again. It's 2y. Let me copy here. 2y plus 16z equal minus 10. And you try to isolate y. Entonces 2y is equal minus 10 minus 16z. And you divide it by 2, divided by 2, you get y alone is equal minus 5 minus ac. Okay, I copy y as a function of c is minus 5 minus ac. Okay, leave it like that. You can, but no, more elegant is the solution is the triple order x, y, c, but c is the free. So it's x. Who is x? 1 plus 4c. Comma. Who is y? Minus 5 minus ac. And who is z? C is z. Que free. And this is the solution set. So some book in Alex, they want that way to express the infinity many solution. Remember, infinity many solution is a bunch of points. Maybe it's a line, maybe it's a plane, but contain the amount of free variable according to the objective. See, the objective is a line, it's one free variable. See, it's a plane, it's two free variables. Let me try, I create a simulation to see the idea. Okay, this is no good. I did that. That one corresponding with this problem. I make a zoom. Make a zoom. Make a zoom. And you see we have three equations. The equation Cian, this equation 1, this equation 2, and the red one, equation 3. And you see that there are no point common, but it's a line common. And this line is represented algebraically for this. Guys, do you follow me? Okay, super. I know that this is complicated. I promise that in the last part of this chapter, we study more clear using another sophisticated tools, because so far we are doing everything by hand. But no. When you are professional, you solve the system using software. I want to illustrate how. And how I want to illustrate the organization for plugging inside the software, and you obtain the result, and you analyze infinity many solution, how many free variables we have, everything. I bring one more example. Bueno, so you have no question, no? Everything is clear, guys? Or no? Yes or no? Answer me. Are you there?
Yeah.
No.
Yes. Yes.
Okay. Okay. There you go. I have another example. Example 8. Que bring me a new situation. Es x plus y plus z equal to equation 1. 2x plus 2y plus 2c equal 20. And equation 3 is minus 5. Wow. Minus 5z equal minus 50. What do you think about this system? It's very, very weird. Do you see something weird or no?
Yeah.
What do you see?
That all turn out to be the same equation.
It's the same. If you take the equation 2 and divide it by 2, it's obvious that you get the equation 1, no? And you have the equation 3 and divided by -5, you get the equation 1. Therefore, you discover by intuition, that equation 1, equation 2, and equation 3 is the same equation. They are the totally dependent equation. They are not independent. Now, you know that each equation is a plane. It's actually, we have 3 planes that is coincident, the same plane. Now, we have, in this case, the solution is a plane. Okay, actually is the equation 1 or the equation 2 or the equation 3. Personally, I like equation 1. It's easier because the coefficient is 1, 1, 1. Now I take it, okay, we have in this case 2 free variables. How do you know that we have 2 free variables? Because in this case the solution is a plane, no line. When it's a line, it's 1 free variable. When it's a plane, it's 2. Because the dimension for the plane is dimension 2, degree of freedom is 2, and degree of freedom here is 1. It's two variables. Okay, you declare, for example, that you take y and z free is any real number, but x is non-free. So you, as always, write the solution like that: x, y, z. Who is x? Now, x you take, for example, you take the first equation and you isolate x is equal to 10 minus y minus z. So now in our specific problem is 10 minus y minus c, comma, y and c are free. And this is the answer. Okay, and this represents a plane. By the way, I want to see in the simulation. This is another thing that you should do now in Calculus 3, that the student can need to take Calculus 3, you see a graphic plane in 3D, but no here. Look at that. This is the system. I discover the green plane, the red plane, and the yellow overlap. I don't see the yellow. I see only the green. And one piece of the red is coincident. Therefore, the solution, the common point in between the three equations is a plane. And this plane is represented by this notation. Look. It's a plane. That plane. Okay. So I spend the rest of the time today doing applications. In what part I apply linear system of equation? Okay. You applying any problem, guys. I bring 3 problems, 2 easy problems in 2D, and 1 problem in 3D. Okay, let's do it. This is application problems. Let me focus in this. Okay. This is the classical. Now with the coronavirus in the hospital, I need to disinfecting something, no? So in the hospital using 15% bleach solution to disinfect the quarantine area. Okay. However, we have available another concentration, it's not enough or too much. We have one container, is that one, can have 6% concentration. What means 6% concentration? That means if we have one container, look, and if we have some volume, some liquid, 6% concentration means that we have 94% of just water and 6% is the pure bleach. So it's a mixture, it's a combination. In the container, put one volume of water plus another volume of the bleach, but the proportion between these is only 6%. It's not enough. We need 15. 15 is a good disinfectant. It's a good. I need that. But in the store, maybe I have available 6%, not enough. But we have 18. It's too much. So what is the goal? The goal is I need 50 liters to do a job right now. 50 liters. This is the volume of this concentration. But I have available this. Okay, I want to call X. X represents the volume of the container, o sea, the liquid I extract, withdraw to put together. So basically, this is my problem. Schematically, let me try to, guys, when you have a word problem, you read the problem, try to understand the problem, and create your equation. This is the new challenge. In the homework online, you have one container, 6% concentration. We have another container, 18% concentration. But I need another container que have 15% concentration. Now making sense, right? Making sense that the total or after the concentration after the mix is intermediate value and between this and this. No? Suppose I need 20. 20 is impossible because when you mix 18 and 6, never you get 20. You get, according to the proportion of the volume here and the volume here, you calculate now in order to get 15. And the liters is 50. It's a volume, 50 liters. You understand the problem or no?
Yes.
Okay, cool. Now, I have two equations. How do you know that we have two equations? Well, the first equation is easy. It's the equation for the volume. The equation for the volume. Let me write here. The equation for the volume. Okay, there you go. The equation for the volume total, que incluye water plus bleach, is, suppose the X represent the volume that you're using of this, together Y is the volume plus, because you mix it, you put together, addition, equal 50. Everyone understand this equation? They want to call equation 1. Make sense?
Yeah.
Total volume, water plus bleach. But I have another equation que, in my opinion, is the most important, que es the equation for the bleach alone, bleach. Entonces now, well, this is 6%. Let me try to understand the expression. For example, I try to express this percentage to decimal, okay, divided by 100, 0.06, 0.18. The thing I did was conversion from percentage to decimal, no? And this is 0.50. If you want to compute the liters of bleach inside this container, you multiply 0.06, que es the concentration for the bleach, multiplied by X, que es the volume, que I don't know, by the way, que you put outside this container in order to mix it with this container. And this equation represents the pure bleach. The pure bleach. Make sense or no?
Yeah.
Likewise, you take in this container the bleach. Now I change the color, but it's the bleach. You put together here. Now the expression for the bleach now would be 0.18 Y. This is the expression for the pure bleach that you extract in the second container. And what about the bleach, pure bleach here? Because we have 50 liters, but 50 liters is water plus bleach. But I want pure bleach because my second equation is pure bleach. It's easy. You multiply 0.15 times 50 and give me the liter of the pure bleach. I put in my calculator is 0.15 times 50. It's 7.5. 7.5 liters represent the volume of the bleach inside this container. By the way, what about the water? Well, the water is 50 minus this. 50 minus 7.5. We're subtracting 50. Is, no. Yeah, it's 42.5. 42.5 liters. This is the water, but I don't care the water. I care the bleach because my equation is bleach. So I set out the equation, copy this expression, that represent the bleach you extract in the first container 0.06x, and the bleach you extract in the second container 0.18y equal 7.5. Okay, 7.5 is the bleach total that we have in the last container. So this container has 7.5 liters of pure bleach. So this equation is pure bleach, and this is equation number 2. Guys, do you understand how I set out this equation in this problem? So in the homework, in the homework online, there are several problems. All the problems you talk about the money, or the problem. So you don't understand very well. Remember, you email me with the screenshot. Remember, the problem you see online is different, and the problem I see in my platform, and it's different to another students. So now, when you are doing this, you don't understand. I understand. Okay, you don't understand because it's confusing. The word problem. No? You read, try to understand, and try to set up the equation. Now, I finished. No, this is just the beginning. Now, algebra. We focusing in the algebra between these. But this is the easy part. At least for me, that's the easy part. Okay, to eliminate the decimal, horrible decimal. No good. I multiply by 100. Why 100? Because you have 2 decimal places. Now, when you multiply the entire equation 2 by 100, it's 6x plus 18y equals 750. And this is my equation 2. So I copy my system of equations in elegant way. Okay, I try to do my best for the solution of this. Do you follow me?
Yes.
What do you propose me to do? Substitution or elimination?
Substitution.
Substitution, Why? Where's the reason?
You can't really eliminate the x's or the y's at this point.
The reason is you say substitution, right?
Yes.
Remember, one more time I repeat. When the coefficient is 1 or -1, the best way is substitution. For example, you take the equation number 1, the easy equation, obviously. And you isolate, I don't know, maybe y. Y is equal 50 minus x. And use substitution, this expression, in another equation in the y place here. And you have now 6x plus 18 parentheses 50 minus x equals 750. And this is my new equation. Let's do it. Easy. This is algebra. Multiplication. Distribute the property. 18 times 50. Put in a calculator. 18 times 50. 918. 6x plus 918 minus 18x equals 750. Combine like term. 18 is negative, 6 positive. Subtraction is minus 12. And also, why not? I'm moving minus 918 to the other side. ¿No? Entonces ya subtracting 750. The answer is 100, pero negative. It's a negative 12. This is negative because we put the sign of the bigger number, get negative 168. No? 68. Now divided by minus 20 minus 12, sorry, both sides. Divided by 12. And the answer is 14. Wow, 14, 14, 14. But I don't remember anything. What is 14? 14 what? 14 is the liters of that containers. So it's the liters of the container. They have the smaller concentration, okay, 6%. However, in order to find the other, 50 minus 14 is 36. Y is equal 50 minus 14, y is equal 36. Okay, I checking with my paper, yeah, I making some mistake. Let me see what the mistake.
Wouldn't you have to reduce it because you multiply by 100 the bleed?
Yeah, when you multiply by 100, we have 6x plus 18. Let me check it out. 7.5. Bueno, times 100 is obvious as 750. Okay. The problem is, let me see. Oh. All right, let me check it out. The number. The number is, oh, yeah, 18.
18 times 50?
50. This is a mistake. 18 times 50 is, the problem is, guys, I have no lie here. Yes, 900. 900, 900. This is a mistake, I saw. This is 900. I believe que es 8. 900. 0, 0. Ok, entonces 12, entonces this is 900. And now subtraction. Subtraction is 900 minus 750 is 150. Okay, let me erase that part. Entonces es minus 12. It's a minus 150. Divided by negative 12 both sides. X is equal to 12.5. Es decimal. Put in the calculator is positive. Negative divided by negative positive 12.5. 12.5 liters of this, not 14. However, the other concentration, Y, is 50 minus 12.5. So 50 minus 12.5 is 37.5. Okay, not 36. It's 37.5. In conclusion, I need to mix it 12.5 of this smaller concentration and 37.5 of this too much liter. This is a liter. In order to get 50 liter of the concentration. If you want, guys, let's do in the last thing. It's a confirmation that everything is okay. How you confirm that? When you moving, how you double check it? When you moving, for example, using y and x, no to this equation because it's trivial. Because remember, we computed y using this here. We're using the concentration bleach, que is 6 times multiplication by 12.5, que is x here. I plug in this 12.5 here and 37.5 here, plus 18 times 37.5 would be, see, I am doing well, question mark 750. Let me try. So 12.5 times 6. Oh, make a mistake. let me clear everything. 6 times 12.5 is 75. This is 75. And this is 18 times 37.5 is 675. And 675 plus 75 is 10 carry the 1, 8. No, 8 no. This is 15. Because 7, 14 plus 1, 15. You carry the 1 is 750. Cool. Okay. It's the checking, not necessary to do. But the solution is I need to mix it 12.5 of this container liters and 37.5 of this in order to get the standard concentration get 15. Do you understand very well or no? Okay, next time we continue with the word problem. We are doing 2 more. We start new thing. Remember today at midnight. Tomorrow in the morning I will grade your test. Reading test number 3. Okay? Okay?
Okay,
Bye-bye.
thank you.
All right.
Thank you.
Mm-hmm.